problem in there, 'cause I've been trying to get I've been trying to get my string working all for the past 30 minutes. Dear, finally got it working, I think. Right, oh bloody time. Don't know what was going on with it. Yeah, Alan, I've been trying to get this live stream working for the past 25 minutes and it just wouldn't play at all. It kept trying and then it went off, and yeah, it's just not my day. I was going to go back to bed, you see, but I thought sod it, because I just want to get on with this bloody board. I've got my soldering iron on, I'm wasting power, and I need to get this board built. Right, I've got to transplant the components on this breadboard. Just let me know if the stream goes wrong or anything, because it must be something to do with that crash I had earlier. I've got a Samsung freezer as well. It's a big fridge freezer. Anyway, I've got a soldering iron on, so I don't want to be I don't want to be lingering. Oh, I'll put the soldering iron on, and I'm going to solder these sockets in though, because I want to get them straight, and so I'm going to use a blower blue tack to hold them in place while I solder these. I need to get them straight. Then I'm going to put the resistors in. Normally you put the sockets in last, but I had some issues with the sockets positions on the board, because the sockets, I don't know if you heard me earlier, the design was too close. They were too close together, and I couldn't get them in. So I've had to put one socket in for the outputs and the other socket in for the ground. And I've had to mount the ground at the side there. Well, it's left me look a bit cramped, but I can still get a resistor in there, which is alright. I just want to make sure I've got these lined up properly before I solder. What I'm going to do is I'm going to solder these sockets in, then I'm going to turn the iron off, and I'm going to put the rest of the components in, and when I'm ready I'll put the iron back on again. So it's a bit of a fart-asting about, but that's what you get when you make mistakes. My iron's not very hot. It's quite a large copper area, this, so right, let me just make sure that is straight before I do the other pin. these two pins can be soldered together anyway because they're both ground. Right. Well, that's in. Right, the blue tack can come off now. I've got the sockets in. Right, I'm gonna solder this IC socket in first because the legs of the resistor stand right high up and it's hard to get to the IC. It's not easy to get to the pins on the IC, so I'm going to do that first. Then I'm going to put the resistors in, and oh, I want the other glasses. I want my other glasses. I can't see very well with these on. As he's going to tell me people are watching me again and make me all paranoid. I'll let them. Right, IC sockets in. Right, I don't know if you can see that, but soldering iron wire is probably in the way. Anyway, that's that. Oh, I can't even see the preview. So I've got to do the resistors now, and then the capacitors, and yeah, I put quite a bit of solder on there. I don't like weak joints. hold it the other way as well. Maybe if you can see that. I don't know if you can see that. That's the IC socket soldered. And I had to improvise on my plugs, but anyway, I need to get the rest of the I'm going to switch the soldering off a bit because I need to get the resistors all in. I've got to get all the resistors in now. You're supposed to put the resistors in first, but the problem with that is that it's hard to get to the IC socket to solder it because of the legs that stick up. So I did these sockets first, and then I'm going to put all the resistors in, the presets in. Actually, I can put the presets in now. Actually, I could put the presets in now first. No, actually I won't. No, because I'll get confused about which presets in. Yeah. Let me just think. I could do. Actually, I can tell where the presets go anyway. Let's see. That's for the 1 megafarad capacitor. So that's the that's VR1. So that wants to go. That's VR1, right? So I'll stick the VR1 in. Then I will have less hassle later trying to figure out which, because I've set these up, you see, and I don't want to change the settings. I don't want to change the settings. I want to transfer everything directly over to the board without changing anything, so I can compare it. So VR1. Oh, actually, is this upside down? Right, the left leg goes to the capacitor, so that's the left leg. Oh, that's typical, isn't it? Yeah, it's upside down. Huh. So everything's back to front anyway. Yeah, it's just the way the breadboard is. It's oh well, no worries. I'll set the frequencies up once I've done it, and another way of doing this is to measure it and then trim it round. I just didn't want to change the settings, you see, but when I put this in the board, the left leg goes to the capacitor in the breadboard, but on the circuit the left leg actually goes to the 2-pin 1 of the IC. So yeah. Oh well, bugger it. Oh, it'll be alright. Right, I'm gonna stick VR1 in anyway. I could always take a measurement from it and change it around, so yeah. Oh shit, that leg's got bent. Sorry, excuse my language. Okay, it's gone in now. Right, I'm just going to bend that leg over. And get VR1 in. And I'll do the rest of the resistors. Okay, right, VR1 is in place. turned. Really I want to rotate that 36.6, so if I just turn that trim around, so then hopefully the settings will be the same when I I lost my screwdriver now. Oh, it's here. So if I trim that around so the other one is 36.6, then it'll be the right way around before I put all the other components in. Is this working right? Huh, is this trimmer dodgy? Oh, I see, it's connected to... the other end's connected to... oh, damn it, so I can't change it so it's 36.6 the other way around. Alright, okay, I forgot about that. Never mind. Take my best guess. That'd be about there somewhere. I'll sort that out later. Anyway, I know what the frequencies are anyway. Right, I'm going to switch my iron off while I put the rest of the parts in, because it's running on my inverter, you see. I just don't want to run my battery down. Oh. He's gone poof like a magician. Right, so pin 1 to pin 14. There's the next one to go in. So huh? Oh, alright. Pin 1. Oh, pin 1 is to supply actually. That resistor, so that yeah, that's it. Yeah, so it's upside down. R10 next. I don't want to mess this up and get the resistors in the wrong holes. Ugh, that would be bad. And having to unsolder them again, that would be really bad. Especially after spending an hour or two trying to figure out why it wouldn't work. So you can't really rush this sort of thing. Right, I've got R10 in. I'm just going by pin numbers on here because obviously in the breadboard nothing is listed as... I haven't got anything listed in there, but I did work it out before. So we want pin 13 to supply. So that's... Ooh. 13 to supply, that's R11. Yeah. So R11 is the next one. That's this one. Okay, that one's in. I'll come back to the capacitors later. I want the, oh, these are easy. 100 ohm resistors actually from 1, 2, 3, 4, 5, pin 5 to the 100 ohm resistors, so that's 1, 2, 3, 4, 5. Let's see where they, yeah, that's, I found them. That's these two. These are fusible resistors to protect anything from blowing up. There won't be no magic smoke with this thing, by the way, because I've got fusible resistors. I've also got a PTC fuse in there as well. My magic smoke is in a box. With a padlock on it. God, we're all having internet problems. I wonder if my stream's still working. It seems to be. Right, now the next resistors are for the base emitter. That's these. Base emitter. That's these two. That one, this one. That one, and then now it's Q4 and Q3. So much better with a silk screen. Q4 is the 182L. I better take that other resistor out first, otherwise I'll forget about it. That's between collector, and right, so got that one. That goes on Q. Is it Q4? Yeah. So that's R14. R14. Where are you? Right, R14. Is that right? Oh, right. Oh, R14's up there. Ah, that's why I couldn't see it. There it is. Right, R14's up there. That's the one. One of my transfers, one of the digits is blurry. And I thought it was R14, but it wasn't. I thought, what the hell's going on here? Right, okay, R14 is there. This one right next to that pot. I mean that socket. So it could be a bit of a squeeze, but oh, look at that, it's going in. Yeah, I had to make some modifications to the flipping thing because my sockets were too close. Well, these things happen, but it fits anyway. I found a way around it. R14 is in. Now the B. Actually, I am going to put the BC182L in as well because there's nothing connected to it now, so I'm going to forget it if I don't put it in. And that's Q4. And that should be the one. Q4, and then that's the okay, that's in as well. Got quite a bit of room in here actually, so it's not like I was struggling to get my fingers in there anywhere. And next one is the 212, and that's the resistor that's connected to the diode, and that is to the base. So oh, hang on, I'll just look it up on my diagram. That's what the diagram's for. BC212, and that resistor is to the base and to the diode, and that's R12. So I need to find. I've forgotten where it is. Everything's back to front on here. I'm looking it on the computer, and on here it seems to be back to front for some reason. I don't know why. Where the hell's R12 gone? R10, R13. Oh, found it. Just couldn't see it. It's over here. R12 is over here. That's the one. So R12. Every time I look at this, it looks like a 13. It's not. My eyes are so bad. Right, R12 is in, the diode as well, which is forgotten. It's D5, that's the one. D5 down here somewhere. That's the one. Now the legs on this is a little bit piddly because it's a glass envelope and it can break, so let's see. There we go, perfect fit. Right, that's in. Might as well put the D4 in as well while I'm at it, because right next to it. And I need to sort these legs out as well. That one's in. I've got my germanium diodes in there. I'm going to have to order some more of those. I really have to. My noodle is getting cold. I've got some noodles up here, and I've got my bread, and I need to eat those because they're going to be cold in a bit. I forgot all about them. I always do that. I get my noodles, and I forget my noodles. And then I've got cold noodles. Right, BC212 now. I've nearly got all the resistors just about now. So. Right, 212s in place. Okay, what else is there? God, well, nearly there. This is soon disappearing like a flash. I'm actually going to put this other trimmer in as well while I'm at it. I need to get this other trimmer in. I can't get it out the board. But yeah. straighten these legs. Not that way. Right, that's in. Is that upside down as well? P13. Huh, back to front 2. Let's do that way. Right, okay, I've got that in. Now, biasing resistor, power transistor, so that's between the base and emitter, and that's for the tip 42C, which is the R18, where are we? That's that one. We're nearly there, look, it's coming on really well. We aren't far off. We're nearly there. Now the other drop down resistor is for the I forgot the biasing resistor, that's for the oh shit, I forgot, was up here, yeah, that's for tip 42, that's the biasing, that is, what value is it again? Oh, I can't, 22. Can't read it very well. I've gone overlooked something. When you pull stuff out, 1.8K, so that's the that's R14. Oh, but 2.2K. I must have changed. Oh, this is the older diagram. No, this is R13. 1.8K, that's R13. So R13 where is it? I lose stuff. Ah, there you are. R13, that's that one. R13 is in. Right, okay, those two are the same values, which is the right. Let's see. I want the base resistor is, that's the 560 ohm. That's the R15. So R15. Where's R15? There it is. Right in the middle. Okay. And there's a regulator to go in, which I've got to go and dig out of a drawer somewhere. And the capacitors, which I'm putting last. A test point that can wait. There's the tips to put in. Oh, R19. Where's R19? Oh, that's this one. R19 is the. That'll be this one for sure. And that's between the tip 41 base and emitter. Let's double check. Yep. It's the only one left that's in this section, so. Okay, R19's in, and oh yeah, this is this section now. This section's to go in, so I'm going to put these D7 and D6 in. Let's get these legs spaced out right. diodes are in. Right, oh, we don't even need heat sinks, so I'm going to take them heat sinks off there for now. I'll put the transistors in last actually, just to stick up so much. Put the transistors in last. The compensation capacitors, I don't need those, but I've left sockets for them in case I want to put them in. Oh, right, these capacitors down here, so this is the critical one. I need this timing capacitor in here. Hopefully I've got the holes so that I can find an appropriate hole placement. These legs are so tight. Tolerances are just so ridiculous for these capacitors. If I push them in too hard, the legs can break off. That's the problem with them. Because it's like they're on some kind of silver foil. I'm not sure. I think I've got a couple of these, so I don't want to break it if I can help it, but if I do, I'm going to have to find another one. Actually, it would have been better if I'd made that hole a slotted hole. I might even do that. I just need a bit more room in there. This hole is so tight. I'm making an oval shaped hole because there's extra pads in here. That's what the extra pads are for. Somebody asked me before why I had extra pads all next to each other, and it is because this timing capacitor uses, I've actually joined some of the holes together to make a slot because these capacitors are extremely fragile. I'll show you what I mean. I'll hold it with my tweezers. Now if you look at these types of capacitors, you'll notice that they're let's see if you can get it on the camera. Why is it not showing up? Right, okay, I've got that. I need more light. Right, the legs are just literally stuck to the sides of these things, and if you don't get them in exactly right, if you force them into the hole, the legs break off the ends. They're actually audio capacitors. They're very unusual. I've had these a long time, but I don't know if they're still sellable. I think you still buy them online, but they're actually, I don't think they're cheap because they're audio. They're kind of they are fragile though. That's why I'm trying to be careful. Right, so I've got a slot for this capacitor, so it should fit without any problem. That other hole is still a bit tight, just needs one hole drilling out a bit more. I'm going from the top actually. Yeah, I'll just drill them a bit more, but I think that'll work now. Yeah, it's a nice snug fit. Sits really nicely on there. I need to get these soldered in soon. That's going to fall out though, unless actually I'll put some blue tack to hold it. I'm going to eat my noodles, they're going cold. So I'm just going to put some blue tack on here to hold it in place until I've got it soldered. So if anyone says what's that big hunk of blue tack doing on there, well, it's only temporary, just so that it's meant to be temporary anyway, just so I don't lose that thing. Right, okay, I've got nearly all the resistors in. Actually I think I have got all the resistors in. It's capacitors now, so there's these capacitors to go on, and they go at the top here. And I am a bit cramped because I have to rearrange these sockets a bit, you see, so oh well, it's good. I can get the wires in, that's the main thing. Let's roll around, positive, negative, yeah. Yeah, I think they're only small, these capacitors, so I'm not going to take up much room. And then I'm going to eat my noodles, and then I'll do the soldering. Because I don't want to eat my noodles with solder up my nose, you know. I'm going to lead them a little bit for now. Right. C7, I forgot what C7 is. Oh, that's 100 microfarad. I'll do that one later. I need to find a voltage regulator, my MFR fuse, that's this, that can go in. I'm bending the legs a little bit out so that things don't fall out. That's electronic fuse. It resets automatically. It's 100 milliamps, so that's in place. Oh yeah, I've got this other capacitor that's between trimmer. That's 1, 2, 3, 4. Pin 5 of the IC. So I've forgotten what it is now. What's the value? 5 of the IC. What's it? I've forgotten now. Huh? Oh, that was I was using that for the scope, for the oscilloscope. We don't even need that. That was for the external trigger. No wonder what I was confused there. The other caps are just power caps. I can sort them out later for the regulator. Did I do R10? That was 10k. Did I do that one? Yeah, that was there. I hope I got that on the right pulse, isn't it? It should be 10k. What the heck? R10, hang on. Got something wrong somewhere. R10. Hang on, did I update my diagram? No, that should be 10k. What the hell have I got 3.3k in there for? Unless I forgot to update my diagram. It's not a big deal because it goes through a trimmer, you see. That resistor goes to discharge into a trimmer. I think I might have. Oh, I might have lowered it actually. I think that was the 10k is the generic value. Yeah, I got 3.3k on the other side, so let's have a look at R11. How's that one? See. Oh, is that it? Oh, right. Oh, maybe I've got the wrong way round. Ah, that's probably what I've done. Doom, doom, doom. If that's 10k, then I've got it wrong way around. No, that's 1 point. That's 1.7. That's okay. R11. Yeah, I must have changed those and I forgot to update it on the diagram. I need to do that. I'll just write it on here actually. 10. Oh. So that's, I'll change that to, not critical because in series with a trimmer anyway. What the heck? .7K, so that's 1.7. And R12 is actually, no, R10 is actually, I changed it to 3.2, so that's right, 3.2. So those would generate values. I think I'm just looking at an old schematic. I think I've got the older one there. I think I updated those, I'm sure I did. I'm going daft. I'm going to have my noodles because we're nearly there. Oh, I've just got capacitors ready to put in. So ignore the blue tack. I can't get this in here with all the resistor legs. There we go. And there's it. Oh yes, that capacitor. That's the timing capacitor. Let me just pop that in a minute because I forget about it. That's the 1 microfarad. That goes to, that's C1. So C1. Oh, C1's down here. Ah, right. Positive, negative. C1's right in this bottom corner. I'll just sort this out. Right, okay, blue tack's holding the other capacitor in still until I get it soldered. Right. Okay. I can look at it while I'm eating my noodles and just think about stuff and make sure I haven't missed anything out. So I'm going to mute the sound. You don't want to hear me noshing. Right, I've had my noodles. I'm just gonna go and get my my pot away thing. I'm going to put the capacitors in and I'm going to start soldering. There won't be any smoke. See that? It's 100 milliamp. It's 100 milliamp PTC fuse, and that's the first thing in circuit. It supplies everything. If there's a short anywhere on this board, the power will just get cut off. And there's a protection diode actually goes in here, which I forgot to put in, which I'm going to put in now. So if I reverse polarize it and put the power supply to the wrong way around, this diode will short the circuit out, causing that electronic fuse to cut the power off, and it'll prevent my ICs and anything else from being damaged. They used to do this in CB radios actually years ago. Put a diode directly across the power supply, so you can't, if you reverse it, you actually short the diode out. But they didn't have they didn't bother to put PTC fuses in, which was stupid. They should have done. I suppose they were too expensive back then in the 80s. I don't even know what the smoke test means to make it. I've never seen it. A puff of smoke. Actually, there was one time when I did see a puff of smoke, but that was because I put the circuit board down on a piece of metal and it shorted something out underneath, and that was a different metal though. That was just clumsiness. And stupidity, whatever. Right, I need some capacitors for the power supply. I'm not fussy about the values really. I've got a 220. Oh, there's a resistor of what's that for? Oh, that's for the oscilloscope. That's the output capacitor. Right, this is to go in. This goes up here. What's that? Positive, negative. That should pop straight in there. Perfect fit. Got a few of these capacitors actually. Right, that shouldn't fall out now. It doesn't. And I could stick this 1000 microfarad capacitor in. Let's see where that was going to go. I can't find my regulator. Oh, there it is. Right, regulator output ground. Can't see the damn thing. ground on that side, so it's straight on this side. There we go, that goes in like that. The legs are already short on this, so that's going to be tricky to bend these legs over because they're so blooming stubby. I might not be able to do it. I might have to just solder it straight in. Oh, I can do it. Right, okay, that's in. That's not going to fall out. Put that capacitor in. We're not far off now. Move the light a little bit because it's very bright. That 1000 microfarad is a little bit tall actually. I'm not really keen on it. I don't want something too sticky out, you know what I mean? It's very tall. I'll find something smaller. I don't have to use a really big one. Yeah, most of them are. Just the power transistors to put in, which I'm going to do last, because I've got to think about heatsink. I might fit a heatsink on them first. I don't know. I probably can't do that anyway. I'm probably going to have to find something. I might have to make a heatsink that's with the holes drilled just in the right places. I can have a conjoined heatsink now, you know, so that both of them share the same heatsink because the collectors are actually connected together. So, and I don't even need thermal, the electrical insulation like I did before. Right, I might be able to use that. What's that one? That's 470 microfarad. A 470 microfarad is probably going to do this actually. It's not a brand new one, but well, it is new, but it's been lying around for a long time. Oh, actually, I've got some with legs already trimmed off. So why don't I use one of these? Let's see. That's a 220. That's a high frequency, 220 microfarad. I could use that. Just to show you, I could use that or that. But that's got legs on it. I might use one with short stubby legs already. What else have I got? I've got another 220 short legs. Well, I could use either one of them because they're good. Don't really need 1000, not for this. That's another 220. I've got a load of these, so I'm going to use one of these 220s. I need to get them back into circulation. Otherwise, I end up with loads of capacitors with no legs on hardly. So I don't need 1000 really. Pull that one out again. It's a bit too overkill. That was better. That'll work. Most of the time we're going to be running this from an external power supply anyway, and it's going to have its own capacitors in it, so okay, that's that one in. That's good. That'll work. There's actually two of these, so I'm going to put another high frequency 220 at the top here. It's to stop crowbar effects on the power supply rails. So we have another one up here, so that's perfect. I can actually put two of these in. So two 220s, that's 440, so that's more than enough. Have I drawn that hole out properly? Yeah, I have. I won't go into it for a minute. Blob of solder on it, I think. Get my pliers and just bend those legs because they're so small I can't get my tweezers on. Ah! Okay, that's fine. Right, so we've got capacitors in. Now I'll put soldering iron on in a minute. Power in socket. Power in socket. I won't forget that. Legs want bending in a bit. I'll get it in the hole. There we go. Right, there's a power in socket. That's in. Need to bend them legs out a bit. There we go. So, oh. Yeah, I know that these pots, these terminal blocks are in a funny place. It's because, as I said, I don't know if you heard me, but yeah, I messed up the spacing. So I had to rearrange them. So basically this terminal block is supplying the ground rails. This one is connected across where two terminal blocks would have gone across the outputs. So, and I can still get my wires in from there and round through the back of that capacitor. I can still get my wires in. So when I solder this capacitor in, I'm going to have it like that so I can get my wires in. But it's alright. It's a prototype anyway. I made corrections on the actual software so that when I print a new one out I won't have this problem, but for this particular prototype it's good. It does the job. It'll do the job. And I'm just thinking I'm having a ciggy and got another socket there to go in. Oh, I've got the regulator to go in. That's the test point actually. I've got another position there and that's for a test point, so I don't have to put a socket in there. Well, I could do, because it's also for battery as well. You can also put a battery on there. So I might actually put another socket in there at the top. Because then it'll run on battery, or I can have an external. If we do succeed with Orbi Unity, we're going to have power running back into there instead of through the regulator, you know. But I'll just see if I can get this other socket in there. Should fit. Yeah, snug as a bug in a rug. Yeah, we're winning. I'm not going to put it in a box yet, no. No, this is just a prototype. It's just for testing, and there's no point putting this in a box yet. I mean, those ABS boxes are quite expensive. I could actually, when I'm happy with everything and when I know it's all good, and I actually could even get a 3D printed box designed. I could actually could design a proper box for it even and get one 3D printed. That would be kind of cool. That would be better actually for me than going out and buying a prefabricated box that's the wrong size. That's either too big, because the problem with buying those boxes, the ABS boxes, they might be strong, but they're either too big or too small. You know, you can never find the box just the right size. But if later on it all works out really well and everything, and I'm happy with it, I might actually get a 3D printed box. You know, where I can actually have holes made, printed already in it, instead of having to drill holes and things. I could design holes in the 3D print for things like switches or sockets, you know, plug-in sockets and things like that, and that's probably a better option. And I don't think it'll cost me a lot of money really. It's probably only going to cost me like 15 quid or something, which is probably, you know, cheaper actually than going and buying one of them ABS boxes, because you know, I used to buy ABS boxes for projects all the time, but they are expensive. Well, they might not be as expensive as they used to be, but why not make use of technology and design your own box? And that IC socket, I can just plug the microchip straight in there. I'm going to turn the soldering iron on. Okay, I've turned the soldering iron on. I'm just waiting for it to get hot. God, I'm really running my solar battery down with this solder now, I tell you. Yeah. It's gone down from 11.3 volts to 10.9 volts in the last, no, actually 11 volts in the last couple of days. And I've still got room. I've got about 1/4 inch room there for a heatsink, and I really don't need much of a heatsink, to be honest. And if you look, I've got a space right between these capacitors where I could have a long piece of aluminium heatsink coming through, and I could have an L bracket and bolt it onto something on the outside even. So I could technically, I'll just find something. I could technically have a heatsink. Sort of, this is a bit of backplate off a computer, but the transistors are actually going there and there, and this piece of metal would fit a thin piece of metal, or well 2mm thick, would fit all the way along that stretch, and then I could right angle bend it like this and have a heatsink running inside a box to take the heat away if I need it. If I need to do that, that's if I need to do that. And it's perfectly in alignment. I've got my spacing bang on there. There's just that little diode, that's a protection diode there, and that's actually connected to ground on the back here. So that leg of that diode right here isn't going to short out on anything because it's already connected to ground, and if the heatsink's resting on that leg even, it won't cause a problem. So I've got that all good. That's a protection diode anyway. So that's really what I'm planning on doing. And the heatsink itself could also act as a further anchoring point as well. I probably need to film this on my phone actually. I might actually make a phone video just now in a minute. It might be a good idea because I can get some close-ups. So I'll get my phone and I'll make another YouTube video. Right, I'm going to make a YouTube video. Right, I've been building my circuit, and I've got all the components in the board ready for soldering, well except for the 2 power transistors. And I've just been explaining to a friend, the heatsink can actually run along this plane here and actually come into contact where the transistors go, which is the transistors are going to be mounted actually there and there in these holes here, and a heatsink will run directly behind the actual transistors. I mean, I can have a right angle bracket, but this metal, I'm not using this. This is just an example, just to show you what I'm doing. But it could be right angled and then bolted to a chassis or something to dissipate heat. But at the moment the circuit is actually only going to be pulling around 25 milliamps, so I'm not worried about heat sinks right now. By no means am I, because it's running very efficient. Well, it was on the breadboard, which I've just unplugged it all from. That's why there's jumpers everywhere, but no resistors, because they're all in here now. And so I'm in the process now. I've just got all the components in. I've got to solder the wires, and I'll just give you some nice close-up views of that, because live stream doesn't always do it justice, even though I've got a higher definition camera there. Some of the components are already soldered in, but I've got to solder the rest in. I did make one blip, a big boo-boo actually. There were supposed to be 2 sockets here back to back. Unfortunately I went and got them too close together, so I had to rethink that, and I decided to put the 2 ground, drill some 2 extra holes and use the black socket for ground, so I could have 2 grounds going in for the other ends of the coils, and the blue socket is now providing both outputs for 2 separate coils. So that works out. Now can I get access from the side and from the end if that capacitor is not in the way? Well, obviously I'm going to leave it soldered at an angle so I can easily get my wires into the blue socket, so it's not going to be a problem. Once the wire is soldered in, then the capacitor can be bent up if necessary. But yeah, anyway, we've still got the transistors to put in, but I haven't put them in yet because I've got to dismount them from the heat sinks that they're in right now. So, and the IC socket's there, so basically all I have to do is unplug the microchip from the breadboard and plug it straight into the IC socket. And a bit of blue tack there is holding a tiny capacitor in place, which is a bit fragile. I don't want it to fall out until I've got it soldered in. So yeah, that's the only reason for the blue tack. Anyway, that's just a short 4-minute-ish update on what I'm building. And this circuit is actually designed to drive the solid state bubbleator magnetic switch. So, and it's also gives out dual frequencies to optimize the efficiency of the drive circuit, so that we don't have excess amounts of loading and wasted energy generated by heat. And the amount of heat generated is minimal actually because of the resonant behaviour of the circuit. Anyway, there'll be other updates on this as we progress. Anyway, thanks for watching. Right, so I made a video that's going to be on YouTube in a little while. I'm just going to transfer it over to the computer on the Bluetooth. Do that now. Okay, that's on its way. My soldering iron should be nice and hot now. Oh, where's that water come from? There's water down here. Where's that come from? That's odd. Unless it's me spitting. Probably. Yeah, I'm just finishing my coffee off, and then I'm going to carry on, and I'm going to solder. There's one capacitor there that. What's that one for? In one. Hang on, what is that? C7? Have I missed C7? Or has it fallen out? C7? Pin 1 and ground. Hang on a minute. What's C7. I think I've dropped. I think I've lost the capacitor. I'm not on it. C7. Where the hell is it? Oh, that's the 100 microfarad. Ah, okay, right. I need to stick 100 microfarad in there. It's for the other side of the regulator. No, actually, no, Alan. The 100 milliamp fuse is connected primarily to the well, it's actually connected to the whole circuit now, but I could always change it, you see. If I want more power out, I can replace the 100 milliamp with a bigger one. I have got some other PTC fuses, like this one, and that's like I think that's, what was that, 1.85 amps, that one. That's another PTC fuse. That's 1.85 amps, and it actually trips at about 3 amps. So if I decided to put a bigger fuse in there, I've got the option there. But I'm just saying, I want the heatsink in the design. Obviously, if I decide to put it in, if I decide to go that way, ouch. Let's see. I need to put a bigger capacitor in that other hole. Let's see, what's this one? That's 470 microfarad, 16 volt. Oh, that would work. That's small. 16 volt. No, what is that? No, that's only 10. That's too small. 10 volts is too small. What's this one? It's another 220. I want something a bit smaller for the other capacitor slot. That's an actual. What's this one? Yeah, 47 microfarad would do. That'll do for C7. You don't have to be precise with these things. It's just smoothing. It's just to remove any high frequency noise that might come back into the circuit, really. So, so C7. I can't see the negative on it. I've forgotten which way is which. No, negatives at the top. Right. No, that's not negative. Yes, it is. Yeah, that's negative. Right, negatives at the top. Right. Well, it's a tight fit, this. Oh. I've got a blob of silver on here, that's why. Or something, the leg's bent. There we go. Right, I've got that in. I marked it with a red dot. Why did I do that? Hang on, let me just double check this. capacitor check. It's just, it might not be a good capacitor. I realised I'd marked it for some reason. Oh, is it dead? No, it's not. It's good by the. Oh, is it short circuit? Let's try it out. Something wrong because I put a red mark on it. I usually mark capacitors, which I'm questioning. I'm not sure why. Well, that charged up fine. See, it's fine to me. I'll check it on the other meter. It can read a bit higher, I think, than this one. Right, I'll stick this one on 200 microfarad. It says 47 microfarad, so it should read. It's reading 42. Ah, that's probably why I marked it. It's a bit low, but that's good enough for me. It's good enough for this. It reads a little bit low, but that's okay. Right, time to start soldering. I'm trying to get this level. That stupid disket. This stupid thing's getting in the way. Can't win. I'm trying to rest it on these components in this box and it's just not sitting flat. Oh well, that'll do. Solder. I'm going to start with the sockets actually, because oh, flipping wire. There. Usually I just solder one leg of certain components in case I need to adjust. Now this is that capacitor that's fragile, so I need to be fairly quick, but just being awkward. Right, I can take that blue tack off. Yeah, it's going alright. It's soldered. It is at a funny angle. I'll just try and correct it. Oop. That's it. Right, I'll do the other end now. I went and bent these legs over when I caught it with my finger earlier, so right. This heatsink area is quite difficult to do. Too many wires are in the way. It's time to get some of these wires turned off, because it's just driving me batty. All these wires in the way. I can trim a lot of them off now. Where's my thing gone? Oop. Right, just get the rest of them soldered. It's better. It's not as much clutter there now. I can see what I'm doing. When wires get in the way, it's just really annoying. Oh, you have to shout me if the stream goes off. We're at 2 hours and 5 minutes according to the stream, so I'll need to save it in about 50 minutes or 40 minutes might be best. I've nearly finished actually, so and I could actually put it in the photo scanner and take a picture, or I could just take a picture on my phone, whichever. I'll probably just take a picture of the phone because it doesn't focus properly on printed circuit soldering. I've still got a regulator to find. I've got some lying around. I am not forced to put the regulator in yet though. Okay, I think I've got it. Oh, it's just some transistors to do. Okay, I think that's it. I need to just double check under my magnifying glass that I haven't shorted anything out. Yeah, transistors, I knew it. This flipping soldering iron. A foam is disintegrating. Look. I'll have to find some more sponge. I've got a blob of solder where it shouldn't be. Always happens with these flipping transistors because the legs are so close together. Why does it always have to... Why does these transistors always give me trouble? No, I've tinned the track, I didn't want a tin. Oh well. Shit. I'm not kidding you, every time I solder these transistors, these little ones, the BC182Ls or the BC212s, the pad's always too close. And I've missed a leg there to solder, that wants soldering as well. Okay, let's check that again. Yeah, that's good enough. I don't want to get solder all over the tracks because I've got solder down some of the tracks. I'll clean them up later. But it's all come out pretty good actually. If I'd tinned all the tracks, it would have looked alright, but let's chop these legs off. Right. Oh, there's two more I forgot to solder. I can see them now. I couldn't see them before. Oh, I've lost them again. Where are they? I keep doing that, you know. I'll see something like that. Oh, where's it gone? I lost it again. Hide and seek. Oh, there we go. Found it. Oh shit, I soldering it. Oh, you bastard. Sorry about the language, but I dropped the soldering on the floor. I nearly burnt a hole in the carpet. Damn things. It's this spongy stuff as well, it's just falling out. I'll be glad when I've done this soldering, I tell you. I'm getting too old for this. Can't cope with it anymore. I'll see if I can clean these tracks up a bit because I don't like the way they look. Just after where that I went and got solder down the track, and it just looks really tacky. I need to tidy that up a bit. Clean my iron. Short them pins out again. Can't see through that because the sockets are there now. Yeah. I think that's it. Yeah, that's okay. There's a little bit on there. I just want to get that bit there. Right, I just need to turn my iron off a bit because I'm not going to put the output transistors in just yet. There's nothing to stop me testing it without them in, you know, just to check the oscillators working, everything. I want to clean this up with my cotton bud and some stuff. Oh, I don't know. I'll turn the stove on. My battery's going down. But we're nearly there. The reason why I don't want to put the power transistors in just yet is because I want to see if I can find some heat sinking and see if I can actually hold them, mark the heatsink off and cut it with my tin snips, and in a couple of hours I'll be able to make noise, you see. So then I could drill some holes and bolt it to a piece of metal or something. It means taking them out, you see, and bolting and then putting them in, then soldering them both in together. That's the thing. If I solder them in now, it's going to be hard to get them out if I want to mark them up, and you know what I mean. I could solder them in, but it's just, yeah. I just think it's easier to actually just drop them in, get a piece of metal or something, a heatsink, mark it off, and bolt them in first. Oh yeah, 2 hours and 23 minutes we're at. Yeah. What's this? C7. That's a hit on my battleship. Oh right, I'm not sure what you mean. Okay, Alan. Well, actually, it'd be a good idea for me to save the video. I'll just clean this bit up and then I'll just before it crashes. If it crashes, I could lose the live stream on the other end. So it's probably a good idea then, actually, if I just well, this is what we've got anyway. It's come up. I'll try and show you on the magnifying. Let me get the preview window up. Oh.